Hello friends, in this presentation we are going to see one of the statistical quality control tool, that is control charts. Now we know that every manufacturing process is going to have certain amount of variation. So that means variation is inherent in any manufacturing process. These variations are caused by two reasons. One is variation because of chance causes and variation by assignable causes. If the manufacturing process is having a variation due to chance causes, then we call that variation as acceptable and we conclude that the process is under statistical control. But if the variation is caused by the assignable causes, then we say that the process is not under statistical control and we try to identify those causes and try to eliminate that causes also. That means we try to bring the manufacturing process under statistical control. The control chart technique is one of the pictorial tool which helps us to identify whether the manufacturing process is having assignable variation is because of assignable causes or chance causes. As far as the presentation is concerned, in this presentation we are going to see what is meant by control chart, then the principles of control chart, type of control charts, rational subgroups and technique of control chart, and then in the end we will see what is 3 sigma control limit. As I said, the variation caused by assignable causes are not allowed as far as the manufacturing process is concerned, and therefore our aim is to identify those variations. Control chart is a technique, it is a pictorial tool which helps us in identifying the causes of variation, whether the variation is because of chance causes or whether the variation is because of assignable causes, and try to identify those variations. This technique is introduced and developed by Dr. W.H. Sheward. It is a simple pictorial tool for detecting unnatural pattern of variations in data resulting from our manufacturing process. It is a powerful tool of discovering and correcting the assignable causes variation if they are of course present outside the stable pattern of chance causes, which are allowable variations. They provide a criteria for detecting lack of statistical control. They are very simple to construct and easy to interpret and tell at a glance whether the sample points lie within the tolerance limit. A control chart consists of 3 horizontal lines, right? The central line to indicate the desired standard or level of the process, then upper control limit, that is UCL, and then the lower control limits. That means 3 horizontal lines are there in any control chart. This is basically the diagram of control chart. Here you can see that the upper control limit as well as lower control limit are shown using the dotted line, whereas the 3 sigma whereas the central line is shown using the solid line. If our observed values falls in this particular region or in this particular region, then we say that the given process is having a variation only because of chance causes. But if the observed values falls outside the limit, that means in this part or in this part, then we say that the given process is having a variation because of some unnatural causes, that is assignable causes. Now, as far as the control charts are concerned, there are two types of control chart. Control charts when the standards are given. When the standards are given, we try to compare the observed values with the given standards and try to check whether the variation is because of chance causes or because of assignable causes. That means our aim is to discover whether the observed values of, for example, x bar, sigma, p, etc. for a sample of size n differ from their respective standard values, for example, x bar dash, sigma dash, p dash, etc. by amount greater than what should be attributed to chance. The standard values are either specified by the authority or established by the experience. That means such charts are used for maintaining the quality uniformly at the desired level. The level is specified by the given standards. Sometimes standards are not given. So the second type is control chart with no given standards. In such cases, we try to check whether there is a variation among themselves and whether that variation is above what should be attributed to chance. That means our aim is to discover whether the observed values of x bar, sigma, p, etc. for a sample size n vary among themselves by amount greater than what should be attributed to chance. Generally, we do not have any prior knowledge, therefore the standards are not given. Hence, we use the process to estimate the parameters, and the aim is naturally is to check what is the consistency of our manufacturing process. So such charts are used to detect cause of lack of consistency in the system if the variation is because of assignable causes. Now, the idea behind this control chart is based on the rational subgroup, right? That is basically the fundamental idea. Here, the fundamental idea in the use of control chart is the collection of sample data according to what Shewhart control chart technique called rational subgroup concept. It means that the samples or the subgroup should be formed such that the variation within the subgroup is negligible. That means even if variation is there, it should be because of chance causes, and whatever variation is present there in the system, that should be between the subgroups. So subgroup should be formed such that it is as homogeneous as possible. The rational subgroup concept means that subgroups or samples should be selected in such a way that the variation within the subgroup may be attributed entirely to the chance causes. Systematic, that is preventable or assignable variation, if it exists, can occur only from one subgroup to another. In other words, the product within the group is assumed to belong to a single homogeneous population. The difference between the subgroup, if any of course present, will indicate the presence of systematic or preventable variation. Now, why 3 sigma control limits, right? So we have seen earlier in the diagram there is a band of 3 sigma control limit. That means the distance between the central line to upper control limit or distance between the central line and lower control limit, the distance was 3 sigma. So why 3 sigma? So let us see the reason. 3 sigma limits were proposed from various consideration, and one of the most important consideration is the probabilistic consideration. Let theta be the population parameter under consideration and x1 to xn be the random sample of size n taken to study the characteristic, that means the quality characteristic we are talking about. Let t, which is a function of these sample values, that means the t is a statistic. Suppose it follows normal distribution with parameter mu t and sigma t square. Naturally, then T minus mu T upon sigma T will follow normal distribution with parameter 0, 1, that is SNV. So using biometric table, we get probability that T minus mu T upon sigma T less than 3 will be equal to 0.9973. In other words, it means that probability that mu T minus 3 sigma T less than T less than mu T plus 3 sigma T will be equal to 0.9973. In other words, the statistic T is going to lie within this particular interval. The probability of such event is 0.9973. In other words, the probability that a random value of t goes outside the limit of this mu t plus minus 3 sigma t is 0.0027, which is very small. So t going out of the limit is very small. Hence, if t is normally distributed, the limits of variation should be between mu t plus 3 sigma t and mu t minus 3 sigma t. That's why the 3 sigma control limits. The mu t plus 3 sigma t is called as an upper control limit, whereas mu t minus 3 sigma t is called as lower control limit. And if for the ith sample Ti lies between these control limits, then we will say that the variation is because of chance causes and there is nothing to worry. But if Ti for I falls outside the control limit, it is considered to be a danger signal indicating that some assignable causes are there and it must be identified and eliminated. It means that if the variation is because of chance causes, then we will say that the process is in statistical control, and if it is not, then we will say that process is not in statistical control. In practice, now here we have assumed that the T follows normal distribution, but in practice sometimes the statistic T representing the quality characteristic theta may not follow normal distribution. In such cases, also 3 sigma limits are almost universally used because according to Chebyshev's inequality, for k greater than 0 we have probability that t minus expected value of t less than k is greater than equal to 1 minus variance of t upon k square. This is because this result is because of Chebyshev's inequality. So if we put our values here, then we will have probability that t minus mu t less than 3 sigma t is greater than equal to 1 minus sigma t square, that is variance of t, upon k square, that is nothing but 9 sigma t square. So if we solve it, we will get this probability as 0.89, which is also fairly high. Therefore, basically we use 3 sigma control limits. Now 3 sigma control limit achieve control over two types of errors. The first error is looking for a trouble when there is no trouble. Excessive inspection is avoided because of these 3 sigma control limits. And the second error which can be controlled using 3 sigma control limit is failing to look for a trouble when there is a trouble. So these two types of control errors are controlled using 3 sigma control limits. So now such limits are also very easy to obtain. Why we are using 3 sigma control limit? Apart from controlling the error, they are very easy to obtain, and two limits are symmetrically placed about the central line, and hence 3 sigma control limits are preferred.